right, here we go again. So I hope you're all doing well, finding ways to keep busy, staying up to date with your schoolwork. We are well into physics now. This lesson is on speed and velocity. It is going to involve quite a few calculations, so please make sure you're following along with your notes, writing down the examples, and you should have a calculator nearby as well to ensure that you are getting the same answer that I get. Okay, so by the end of this lesson, you should be able to understand speed and velocity, the similarities and the differences between the two, and be able to calculate these values. So starting with speed. Now, speed is a scalar quantity. So as we learned in our last lesson, this means that it does not require direction to be calculated. So speed, think about driving in a car, how fast you're moving. This is often stated in kilometers per hour or meters per second. So think about speed limits. Okay, let's say 100 kilometers per hour highway speed. So what speed is it's describing the total distance traveled by an object divided by a time interval. That's how we calculate it. So the formula for speed is the symbol for speed is actually a V. Now, we have to kind of start keeping track of the various symbols. It is important that you are using the conventional symbols so that, everybody's on the same page. We can't use an S because S is the unit for seconds. So speed is equal to the change in distance divided by the change in or total time. All right, and as we have over here, it's typically measured in kilometers per hour or meters per second, but doesn't necessarily have to be those units. Okay, so oftentimes you'll see me just write it as V equals D over T. Okay, distance divided by time. Now we're talking about speed. This could be uniform, average, or instantaneous. Now, most of the time in our case, we are going to be calculating average speed. This means we're taking the total distance the object is traveling and dividing it by the total amount of time. So that's going to, include any starts or stops, any acceleration or deceleration. Now, the reason we kind of calculate the average speed is because it's often very difficult. If you're talking about, let's say, a car journey, there's lots of different motion in between. So oftentimes we just kind of average it. Now, uniform speed is when an object is traveling at the same speed in the same direction for that period of time. This is kind of like your cruise control, okay, where you're traveling at a steady, constant, uniform speed. Maybe think about like jogging at a uniform speed or, like I said, cruise control and driving. Now, very little motion in real life is truly uniform, which is why we often use averages instead. Now, instantaneous speed is going to be speed at an exact time. So this would be, for example, like a radar gun when the police record your speed at that time, right? You can't really make an argument and say, well, I was going slower, but I'm only speeding now, all right? So they are tracking your instantaneous speed. Okay, let's just get straight into examples on how do we calculate this. So Jose rides his bicycle from home to school. He travels 6.2 kilometers in 0.55 hours. What is his average speed? All right, when we're doing calculations, it's important that you show all of your work and that you follow kind of a general format. So it's always a good habit to first write any of the information you know or you need to know. All right, so he travels 6.25 kilometers. So I'm going to write that down just on my left-hand side that is distance. We now know time is 0.55 hours. So it just helps to kind of get used to the symbols and units. We're solving for speed, so I'll just leave that as V equals unknown. So now based on these are my kind of three variables that I have involved, I can figure out that my formula is V equals D over T. Okay, very important first step. Now I substitute in my numbers. And I calculate. So 6.25 divided by 0.55. So that's going to give me 11.3636, and that 36 is repeating. I'm just going to round off to kind of 2 decimal places, and it's very important to include units. And because it's speed, we don't need a direction. Okay. All right. So if I were to kind of mark this as, let's say, a written question, I would look that you showed me the correct formula. I would look that you showed me substitution and showed me the work involved, that you have the correct answer, and that you have the correct units. Okay. So all things that are important. Okay. Example number 2. A rocket moving through space travels 240,000 kilometers. So again, important to start recognizing what those values are. That's a distance. During the first 6 hours, that's a time, after launching, what is his average speed in kilometers per hour? Okay, so speed, V equals D over T. Substitute in the numbers I know, 240,000 kilometers divided by 6 hours. Calculate that out. That's going to give me 40,000 kilometers per hour. Now, if we wanted to practice with some scientific notation, I could convert that to scientific notation by going 4.0 times 10 to the power of 4 kilometers per hour. So just to get the hang of that. Okay, a rocket moving through space travels 240,000 kilometers per hour during the first 6 hours. What it is his speed in meters per second. So this is a continuation. So I'm going to simply take my answer from the previous question and then do a unit conversion. So practicing that skill. So first we write the value in fraction form. That's 40,000 kilometers per hour. I'm converting to meters per second, so this is going to take 2 steps. All right, hours needs to be on the top of my fraction in order to be able to cancel out. And there are 3,600 seconds in 1 hour. That's my conversion factor. Okay, kilometers has to be on the bottom of this conversion factor, and there are 1,000 meters in a kilometer. Okay, I cancel out my units where appropriate. I multiply out the top, so 40,000 times 1 times 1,000, and divide by 3,600. And that gives me 11,111. I believe that's going to be repeating. Yes, 11,111. 0.11. I'll just leave it at that. That number is repeating. Meters per second. So that's just practicing conversion. Okay. All right. That's what there is to speed. Now, when we talk about velocity, it's going to be very similar. The difference being, kind of what we talked about with scalars and vectors. So velocity, you should actually show this little arrow on top of the V to indicate that we're talking about velocity and not speed. The reason is that velocity is a vector quantity, which means it's actually describing the displacement of an object divided by the time. So really nothing different. The formula is not written differently other than that we're dealing with displacement over time. Okay, so it's going to come down to calculating that displacement when needed. But most of the time, all it means is your answer is going to have a direction. Okay, all right, so let's look at what this looks like. Your family is driving from Edmonton to Calgary. The trip took 3 hours. The distance along the highway is 346 kilometers, and the displacement is 279 kilometers southwest. Calculate the speed. So it is important to read very carefully here. With speed, I'm going to be dealing with distance divided by time. And because we know that distance is kind of the total journey on the highway, and displacement is like the shortest distance from start to finish, or shortest interval. So for speed, I'm going to be taking that 346 kilometers, dividing it by 3 hours. And that's going to give me 115 kilometers per hour. And again, we're talking about average speed here, even though it's kind of, we don't really have to have that, but we are talking about average speed. So that means we can't say for sure that at any point in time, the driver may have been going 120 kilometers per hour or 110 or less, or there was many stops and starts. But in general, again, average is what we're typically looking at. Now, if we were to take the same trip and calculate the velocity, again, just conceptually different, velocity is dealing with displacement. And because displacement is simply the shortest interval between start and finish, it's less. So 279 kilometers divided by 3 hours. Therefore, my velocity is going to be exactly 93 kilometers per hour. And then this is where velocity is important as well. If we have direction, we must include it. So southwest. Okay, so that's a bit of a conceptual difference here. All right, couple more examples with velocity. Okay, during an intense sneeze, a driver's eyes can remain closed for 0.5 seconds. If the vehicle is moving 110 kilometers per hour, how many meters does the car travel while the driver is not looking? So this is actually, I'm not sure, many of you aren't driving yet, but can be pretty terrifying to sneeze while driving. So let's calculate this out. First thing, because we have our time in seconds and our speed here in kilometers per hour, we have to get them kind of in the same units. So because I'm looking for meters and my time is in seconds, I'm looking to then convert this to meters per second. So your first step here is to convert the 110 kilometers into meters per second. So again, more practice. You got to be comfortable with this process. This is just a setup, and this is going to kind of carry throughout the entire unit. All right, so 110 times 1,000 divided by 3,600 is 30.56. And again, I am rounding off here a little bit. Meters per second. Okay, now we can see what we have. So we know that the time we're dealing with is 0.5 seconds. The speed we're dealing with is 30.56 meters per second, as we just kind of calculated. And I'm looking for meters, which is distance. Okay, so this is a little bit different here. We're now working into manipulating the formula. So I still am starting with the same formula. I'm going to still substitute in the values I know. So this time I actually already know my speed. I don't know my distance, so I leave that as a variable. And I know my time. Okay, I'm going to switch colors just so you can see what I'm doing here. What we're doing now is just up. Okay, we are solving for distance, which means we need distance by itself alone on that side of the equal sign. To do that, I have to move the time. I have to move 0.5 seconds. Now, whenever you're trying to move something, you have to do the opposite operation, and you have to do the same thing to both sides. So right now, time is being divided by. So I have to do the opposite then is multiply by 0.5 seconds. And what I do to one side, I have to do to the other side. Okay? These two can now cancel on that side of the equation, which leaves me with distance by itself, which is what I want. So then I'm just left to go 0.5 seconds times 30.56. Distance equals 15.28, and my units are meters. Okay, so I'm simply plugging in my numbers and then performing simple algebra to get my distance. Okay, Max the mouse crawls 1.4 meters west and then 2.77 meters east in 165 seconds. Calculate average velocity. Okay, so we know that velocity is equal to displacement over time. Again, another step here. We have to first calculate displacement. I'm going to do that up here. I could either use method 1, which is using a number line, or vector addition, which is what I'm going to choose to do here. Remember, east is positive and west is negative. So first, Max the mouse is crawling west. So I'm going to use negative 1.44 meters plus positive 2.77 meters. So my displacement here is 1.33 meters, and because it's positive, it's east. Okay. All right, now I can put that into my formula. So again, there's lots of different ways these questions can be worded. So you have to be kind of on your toes, reading carefully, solving for everything. All right, my time is 165 seconds. Now that I have my displacement, I divide by time, and that gives me 0.00806. Follow my units, meters per second. Direction matters, east. So it's a mouse, so it's very, very slow. Okay, last example. A high school athlete runs 1.00 times 10 to the 2 meters. So we're going to practice with scientific notation. In 12.2 seconds, what is his average velocity in meters per second and kilometers per hour? All right, first let's practice with converting this back to standard notation. So remember, this positive 2 indicates that you would be moving the decimal 2 places to the right. So 1, 2, so that's equal to 100 meters in standard notation. Okay, velocity in meters per second. Now, even though it's velocity here, we weren't given a direction, so it's essentially calculating speed. So 100 meters in 12.2 seconds, and that's going to be 8.20 meters per second. Now, if I'm going to convert to kilometers per hour, I could have chosen to kind of separately convert each of those to kilometers and then hours, or I can just choose to convert my final answer to kilometers per hour. Seconds on the top, hours on the bottom, and meters on the bottom, kilometers on the top. Cancel my units where appropriate, but remember, only the unit cancels, not the value. And that would equal 29.5 kilometers per hour. Okay, all right, so hopefully that gave you a lot of examples to go through. I want you to work on your workbook now. Please keep in mind when you're going through your workbook, you will actually see that the answers are already written there for you in small print. That's just there to help you check your work kind of as you go, so you don't get too far without knowing how you're doing. But you are still expected to show the work as I've done in this lesson, and then check the answer kind of key later, right? So there is a required section. That means all of you guys need to do the required questions. The additional practice is highly recommended for those of you planning on continuing in science. And if you're not continuing on science, it's still a good idea, but if you're got too much going on, feel free to just do required. Okay, good luck.